Okay, students, this week we're going to do multiplying polynomials. So before we were adding and subtracting, now we're multiplying. Now we have to remember, one thing we have to remember is that the rules of exponents. So what happens when you multiply like variables with exponents? So as an example, we have 3x times 3x. Well, we have to multiply the coefficients, so that's 9. And then we add the x's here. So this is exponent of 1. So 1 plus 1, that's x to the second power, so x squared. So we have to remember that we have to add the exponents now when we multiply. That didn't happen when we are adding and subtracting because we were just combining like terms. But now we have to remember that when we multiply exponents, we add them. When we multiply variables or terms with exponents, we have to add the exponents. So let's look at that. So this is a monomial times a binomial. Binomial means 2. So then that times that times that, we're distributing. So 6v times 2v, that is 12v to the second power. And then 6v times 3, that is 18v. Notice that there are 2 v's here, so now there's 2. There's 1 here, then there's 1 here. And that's all I want. That's all we're going to do here. All right. Let's do something like this one. Well, same thing here. Negative 4 times v is negative 4v. Negative 4 times 1 is negative 4. And that's it. Okay, so this is a monomial times a binomial. Let's do a binomial times a binomial. That means that you're multiplying 2 terms times 2 terms. We are distributing still, so let's learn to distribute this way. So the way I map it, I do 1 times this times that, and then this times this, and this times that. Now, if I map it like that, it's easier for me to remember to hit every term. And that's the idea here, to hit every term. So multiply each term times each here, and this term times each here. And that's how we're going to do it. So let's start. And then combine like terms. 2 times 6, 2n times 6n, that is 12n squared. Notice that I add how many n's I have. 2n times 1, that is plus 2n. And then inside, 2 times, so the same thing. So 12n. And then 2 times 1 is 2. And now these 2 terms get combined because they have n's. So that's 12n squared. 2 times, so that's plus 14n plus 2. And that's it. That's all I'm doing here. So notice that the 2 middle terms are going to get combined when you're multiplying binomials like that. All right, let's do another one. Let's do this one. So we have x times 6x, that's so that's like a 1 here, right? So that's 6x squared, and then x times, so map it like that if it's easier to see it. X times negative, so that's negative 2x, that's negative 18x, and then that times that is positive 6. And then these 2 terms get combined. So that's 6x squared, and then negative 20x plus 6. Okay, so that is binomials right there. Binomial times a binomial. This is monomials by binomial. All right, so what happens when you have more terms, like trinomials? Well, let's look at those examples. Something like this, right here. All right, so in this case, you have to remember to hit every term with each term. So that times that, that times that, and that times that. And then the inside term, that times that, that times that, and that times that. I map it like that, so I remember to hit every term. So remember, I'm multiplying the coefficients, which is the term in front of the variable, but I'm also adding the exponent. So if, there are 3 x's, then there are 3 x's. or x or k or whatever. So let's see. 7k times 1k squared, that is 7. So that's 7k. How many k? That's 1, 2, and 3. Okay. 7k times next term, so that's negative 14, and that's 2k's. 7k times 7 is 49k. And then that's the first term. Then I gotta remember to go to the next term. So that's negative 3k squared. Negative 3 times that's positive 6k. And then that times that, it's negative 21. And then now that I have those everything together, now I have to combine like terms. Now at this point, be careful with the exponents because I'm just combining like terms. So this one stays alone because it doesn't have another partner there. This one and this one gets combined. So that's negative 14 minus 3. That's negative 17k squared. So that goes away. Notice that it's the same exponent, right? When you add and subtract, the exponents don't, the number stays the same, right? So 49 plus 6, that is 55. So plus 55k, that goes away. And then finally, it's just that one that doesn't have another partner. And that's it. So let's do another one just in case, but that's pretty much the thing here. So remember, you can go either this way or that way, it doesn't matter. This one is just switch the order, right? The little one is, the smallest one is on the side. But it's the same thing. You can go either this way or you can go either that way. You remember you have to distribute with every term. So let's go this way. That times that, that times that, and that times that. And then I remember that times that, that times that, and that times that. Okay, so let's do it. 2n times n squared, that's times 1, right? So 2n to the third power. There are 3 n's. 2 times 6n, so that's plus 12n squared. 2 times negative 4, that's negative 8n. And then my next term, negative 4 times n squared, that's negative 4n squared. Negative 4 times that is negative 24n. And then negative 4 times negative 4, that's positive 16. And then notice that this one, because I multiplied a binomial times a trinomial, it's bigger. So now we have a polynomial here with 4 terms. So this is going to probably look the same unless something cancels, but it won't. Let's see. This one stays alone because I'm just going to rewrite it. There's not another one with a cube. 12, this one and this one. So 12 minus 4, that is positive 8n squared. So that goes away. This one and this one, it's negative 32n. And then plus 16. Notice that it's bigger. All right, so that's pretty much how it goes here. You first have to remember the exponents, the rules of exponents when you multiply. You add the exponents, and then you have to combine like terms like we were doing, adding or subtracting, depending on what you're doing, the sign of the number. Here, I'm gonna map it, but I'm not gonna do it, but it's pretty much the same thing. Now, obviously, at the end, you're gonna have one more term here. It's gonna be like to the 4th power, the highest exponent, because that times that is gonna be n to the 4th power. So it's gonna be a bigger polynomial that you're gonna end up with. So that times that, that times that, that times that, and then again, this one times this one, this one times this one. You have to hit every term. And then you're missing this one. So that times that, that times that, and that times that. So here it's a longer process, but so you have a clue of what you're doing. It helps to map it how I did it here. Okay. All right. I hope this helps.